Welcome back to this new lesson, and in this lesson we are going to learn about relays. So what are relays and what are they used for? So in a car, if you're a person who has interacted with the fuse box, you've probably seen these little devices here. This is what we call a relay, and it's one of the vital components of a vehicle's wiring system. What does it do? A relay acts as a switch. It basically switches power from a low current circuit to a high current device. Devices like the fan, the fuel pump, the starter motor, and so on. They are switched using these relays, because these devices require high current. So that means if we never had relays, we would use very big wires, which would inconvenience everything in the vehicle. So to eliminate this problem, we use the relays. So you can basically switch power from any low current circuit and power your high current device, the fan and so on. So let us see how a relay works, and let us understand the logic behind the relay. So as you I don't know if you can look clearly here, a relay has what we call pins. This is a 4-pin relay, and then this is a 5-pin relay. And if you observe, there are markings on each pin. We have a marking for 30, 86, 87, 85, and 87. What I've done here is a simple sketch of a 5-pin relay, but we'll try to understand how everything works. So, as you see from our circuit, these are like the standard namings. So if you don't find them on it, don't panic. Sometimes the relays don't have these markings, but you can use a multimeter to measure and identify the pins. So from this pin, we have 30, which is the positive. It comes from the positive side of the battery. We have 86, which switches, and we have 87 and 87A. These 87 and 87A, these are what we call they supply power to the load. Let's say let me use, no, this map is not working. Let me say I'm working with a bulb. So these 2 pins here supply power to the bulb. So on a relay, we have what we call the load side and the switching side. So if you observe here, the switching side is 86 and 85. So these pins here have a coil in between them. Let me use anything like this. Okay, just a physical marking. So 85 and 86 have a coil in between them, and 30 and 87 and 87A are like it is like a switching point where there is a clip that either when pin 30 connects to 87, supplies power to the device. 87A, this one, it is a pin that is normally closed. Normally closed means that in a relay, pin 30 and pin 87, it is normally closed. So if you supply power, it will disengage. Okay, let us look at how this relay works. So the relay, how it works, it uses electromagnetic principles. See, when you supply power from the switch, let's say you switched and the power flows through. So remember, this is a coil and this is grounded. So when you pass power through a coil, there is what we call an electromagnetic force that is induced in the coil. So basically, 85 and 86 kind of become a temporary magnet. So that magnet creates a force, and the force pulls the contact points from 30 connect to 87. So as you can see here, if you energize this coil here, 85 and 86, you are going to create a magnetic force that is basically going to bring this point to 87 to supply power to the load. So that is the basic principle. And if you look at a relay, if you look at it here inside, I think you can observe. If you open it, we have our coil here. This is the coil I've been talking about, and you also have these contact points. So this is a 5-pin relay. You see it has a point here. So this is the contact point here, and this point is normally closed, so that means this one is going 87A, and when you energize the relay, this thing will be pulled to this other contact, which is our 87. So I think you've understood the basic principles of how the relay works. So in case the relay is not labeled and you want to identify which points, if it is a 5-pin relay, this one, if you measure continuity between 86 and 85, you get the continuity reading. Between 87 and 30, there should be no continuity. Between 87A and 30, there should be continuity.